This is my mobile or online lecture here for the second part of this casting. If you remember last time, we talked about all of this, the expendable mold uh, methods, and today we're going to be talking about this multiple use mold. A couple different categories: die casting, permanent mold casting. This permanent mold casting is maybe more of an all-encompassing uh, procedure, whereas the die casting is something specific, and we'll talk about some other things today, as well as some plastics and that sort of thing. One of the really important things here when we talk about this decision between doing this would be, so sand casting, that would be a single-use mold versus a die casting, which is an example of a multiple-use mold, really comes down to how much or how many parts are we making, okay? And so what we have here is kind of a graph, the production quantity here, then the unit cost. And so we see that for these lower batch numbers or part quantities, that we don't need to go through all the trouble of making the molds that are going to last for a really long time. You know, we can do something that's a single use mold, and then that will be more cost effective. However, you know, once we get above, you know, up in the couple of thousands or so, then the permanent molds are going to be more cost effective um, per, right? So that's per part. And so that's one of the things that we need to look at when we make the decisions of, do we do a die casting or some other permanent mold method, or do we use the single use mold method, which is you know, like we talked about last time, the sand casting, the shell casting, the foam casting, investment casting, okay, things like that. Other things that we can use to decide between the different methods are charts that look like this, right? Take a look at this table. This is table 13.6 here in your textbook. So there's the sand casting, there's the shell casting, investment casting, permanent mold casting, and die casting is kind of what we're going to talk about today. So last time we talked about really these three and some other categories, and you look at the over here on the left hand side, you see that there's different features here. We talk about, you know, the thinnest features, the simplicity, the complexity, and then the metals. And then the permanent mold casting and the die casting, the multiple use molds, I've got here in the blue. And again, we still can compare these things, right? What we see is that you know, there's advantages and disadvantages, that some have better surface finish, some can do bigger parts, some can do higher temperature metals. Okay, so there's a lot of things that we want to take into consideration. Please, please, please grab your textbook and take a look at these tables. This gives a more exhaustive list as far as uh, how each of these are used. And so you'll want to make sure that you bring these tables either in your textbook or print it out if you've got the electronic version. Bring these tables with you to the quiz. You'll see some things, you know, kind of familiar to this last quiz in next week's quiz as well. Just kind of comparison, which is better for this, which is better for that. Let me talk a little bit now about this permanent mold casting. As you can see, I'm not going to go through and read all this. One of the things I want you to recognize here is the melting temperature, or the comparative melting temperature. Okay, with the sand casting, there's really no limit as far as metals. You know, the quartz melts at a higher temperature than all metals, I guess all. And so there wasn't an issue. Okay, the sand casting works for anything, but what we have here is these permanent molds are made out of metal, right? They're made out of metal. Well, okay, graphite's not, but they're made out of metal. So when you're casting something in there, you're going to need to be able to make sure that your mold itself doesn't melt. Okay, so when you talk about these cast metals, these are aluminum, magnesium, zinc. You know, these are going to be lower melting temperatures than, sure, the titanium. These other things that are much higher temperature, um, just so that these can melt while these do not. Right. One note here is that graphite will need to be used if it's steel or iron, just because that's a little bit higher temperature. Uh, and then the graphite, again, can resist higher temperatures than some of these other permanent molds. Okay, first of these in this category that I'd like to talk about is tilt mold. Now I'm going to use the real high-tech animations here to show you how this works. Okay, so you've got the mold and you are tilting it, hence the name, right? So look at this. So this is the pouring cup. So this is where all the liquid metal goes in, and then, or whatever it is, and then as you lift it, notice that it kind of begins to creep down into all of these spaces. Well, here, erase that, right? So it's going to creep down into all of these spaces, and it's just basically gravity fed. Uh, this is just a photo to give you an idea of how big these things are, right? Do you see this right here? So this is that cup we were talking about, and it tilts up in this direction. In this case, it's looks like a bell or a pedestal of some column. Okay, and these are going to be bigger parts. They're going to be thicker walled parts too, for that reason that you want to be able to get the molten metal down into all those places. Here's another method. Now, this is the way the book shows it as far as this low pressure casting. This is going to be an important figure, so you understand what this figure is describing. I've got this little video here to show you. Okay, over here on the right, you've got the liquid coming in, just kind of collecting down here, filling this well. And then what we're looking for is a pressure differential between here and between this chamber down at the bottom. It's going to be higher pressure and then lower pressure up here in the mold. Okay, and so by pressurizing this, then it causes the molten material to rise up into that mold. And so you can see now, looking at this, right, that the air comes in here and the molten metal ends up going up this tube, up into the mold like that. Okay, now die casting, it's not too different a method, but what you need to understand here is that this is going to be high pressure. Okay, high pressure. So I think many of you may be familiar with die casting. Again, we've got lower temperature melting metals for the same reasons that we've talked about. Here's a little video. I like this. It does a very thorough job of describing this process. Okay, so you can see kind of the molds inside, and over here in this hopper, this is not a hopper. So this is the molten metal over here on the right hand side. And then it's pushed in again under very, very high pressure. You got these nozzles, and that injects it into the mold. And you can see there's the sprues and the gates, the types of words that we've used when we talked about the other casting as well. You'll find those same features here as well. Okay, that's essentially the process. Centrifugal casting, it's similar arrangement. Again, we're kind of looking at the force that causes the filling of the molds with the molten material. Okay, tilt pour, it's gravity. With the die casting, it's a high pressure. Here with the centrifugal casting, it's going to be the inertial forces. Okay, and you're going to see what that looks like. Here's a video. Again, I've got the links there on the electronic copy of the notes that I've uploaded, so you can watch these also on your own. Let me talk a little bit now about the plastics. We're going to talk about really two categories: thermoset and thermoplastic. And so all of these types of methods, casting, blow molding, injection molding, thermoforming, can be used for these plastics or polymers. Thermoplastics are probably the more common, but these can be done to a certain extent with thermoset as well. The primary difference between thermoset and thermoplastic polymers is that thermoplastic polymers can be remelted. Think about a hot glue gun, right? So you heat it up and it melts, and you do something with it. You heat it up and it melts. you do something with it. Okay, so the 3D printers, right? The filament printers, thermoplastics. Hot glue gun, that's another example, right? Thermoset polymers or plastics, that's more like your epoxies, your Teflon type materials, where once you make the plastic, once you solidify it, then that's it, right? You can't re-melt it with temperature. Okay, think of set meaning that's permanent, and plastic meaning that you can reheat it and it will melt again. Okay, so when we talk about simple casting of plastics, that's like we saw. You just have the mold, you just pour it in or push it in or do whatever there to force the molten or not molten, force the liquid material into the mold. Again, the thermoplastics are the main type. Here you go. Thermoplastics are the main type, but not the only type. Thermosets can be used. Another example is of casting category of the plastics is called blow molding. Here's a video that shows that. Okay, that is blow molding. Here is a quick video that shows the injection molding, right? We've seen the injection molding or the die casting of the metals. Now, injection molding of plastic, this is the equivalent of the die molding for the metals. All right, there you go. There's one more that I'd like to show you, and this is thermoforming. This is an interesting one. This is primarily here for the thermoplastics, but you soften a sheet of plastic and then you're able to form it with a vacuum. Thermoforming or vacuum forming, this is also called. There you are. In summary, there is a variety of casting processes. They're different. Look back over in preparation for the quiz next week. Make sure you're familiar with the materials and then the things that go into making the choices as far as which method are you going to use in order to cast your part, whether it's the single-use mold, multiple-use mold, and within the multiple-use mold categories, what the differences are between the different ones that we've shown. All right, thank you very much.